Hello, class. Today's video is going to be on section 3.3, properties of functions. And for the most part, it's going to be pretty graph heavy. Um, there's three main topics we're going to talk about. Two of the three are definitely visual representations of what we're talking about with functions. The third one will be both algebra and graphing. But oh, by the way, if you're wondering why we're skipping 3.2, section 3.2 is basically 3.1, all the function notation and ideas, but nothing but word problems. So I guess if we get a lot of requests for doing more word problems, I can add 3.2 back in. But at this point, I think we got enough to cover. So had to cut content somewhere. So generally, students don't complain if I do less word problems. So that's what we're missing in 3.2. Let's see. Yeah, this is I think I mentioned this in the earlier videos for this chapter, but we are definitely getting into, like I said, the new college algebra content. This is stuff that particularly with the increasing, decreasing constant max and mins that we're going to talk about, that is definitely pre-algebra cursor material. But it follows kind of along with what we're doing. And these at least those two topics are ones that I could ask you questions on them without teaching them, and you would understand the concept for the most part. It's just how you answer the question. And so that's the real challenge of this particular section and of Unit 2 in general, is not so much the concepts, it's getting the right answer to go along with those concepts. So just kind of keep that in mind as you are going through the homework. All right, let's just jump into the notes, and then we'll see where it takes us. Now, before we get started, let me just outline. I don't have the outline in the note outline. So the three topics we're talking about. So 3.3 is properties of functions. All right, so the first property we're going to be talking about is increasing, decreasing, and constant. So if you think of a graph, if I ask you where is it increasing, where is it decreasing, you're probably going to jump to, is it going up, is it going down? And you'd be correct for the most part. Right? It's more technical than that, but yeah. And then we'll talk about constant that goes along with it. The other topic we're going to talk about is maxima and minima. Those are the pool for maximum and minimum. And so if I give you a graph and ask you to identify a maximum, where are you going to look? You're probably going to look at the highest. Well, you already got the idea for max and mins. Right? But again, it's the details of how to answer it and what the language is that we're going to talk about. And then the last thing, not quite as obvious, is even and odd functions. And when this is something we're going to talk about both graphically and algebraically. And again, to me, the increasing, decreasing, and the max and mins, those are the more natural topics, particularly for our class. Even an odd, it really comes down to symmetry of graphs. When I talk about symmetry, like if you fold it, if you think something, hold up something to a mirror and like mirrors itself, that's symmetry. Right. And so that is definitely one of those things that for us, the rest of the semester, we're not going to need to deal with. We will mention it every once in a random while, but this is definitely more of a pre-calculus topic. Okay, so those are the three topics we're going to talk about today. Again, we're really going to be focusing on how to answer the questions correctly. Let's click into the 3.3 handouts. Now, so we're going to start with increasing, decreasing constant functions. Now, since some people might be on to calculus, we're going to look at the formal definition for increasing. If you're really interested, I've got the formal definition for decreasing and constant in the notes as well. This is one place where I'm not going to be as picky about the math language, but I do want to, I wouldn't be doing my due diligence if I didn't at least show you one of these definitions before we jump into the actual. All right, so a function is increasing when on the open interval I for every x2, and those are subscripts. So for every x2 greater than x1, then f of x2 is greater than f of x1. I want to hide the hint there. So if you're going on to calculus, you're going to have to learn to read math statements like this. All right, so let's see what this means. So first of all, when we talk about an open interval, now we've been doing domain and range, from the graphs where it was, intervals. So we're talking about intervals there. So we're talking about an infinite number of numbers, basically what, left to right or up and down, sorry, low to high. But when we say an open interval, specifically what that means is that there's parentheses on both sides because we cannot equal the endpoint numbers. When we had domain and range, when we had specific numbers, we would put brackets on them. One of the things that trips people up that MyMathLab is picky about, which when it comes to tests, I'm a little bit more lenient, is you always have to use parentheses for increasing, decreasing, and constant answers. Right? Never use brackets, and because we can't equal those numbers at the endpoints. And once we get into problems, I'll explain why. But that open interval just means for increase, decrease, constant, put parentheses on both sides of your interval. And then for every x2 greater than x1, and so think about this. If your second x is bigger than your first x, what direction are you going on the graph? You're going to the right. So as we go to the right, then f of x2 is greater than f of x1. So what does that mean? Well, with our function notation, remember f of x is the same thing as y. So we could also say that y2 is greater than y1. It's on a graph. If your second y is larger than your first y, what direction are you going? You're going up. So what this is saying is as we go to the right, we're going up. And so what does that look like? Well, we just did our chapter 2 stuff with lines. So that looks like a positive slope. Now, technically, if we're dealing with curves, we call it rate of change or average rate of change rather than slope, but that's more of a calculus thing. So basically what you're looking for, if you're looking for where a function is increasing, look for positive slopes. And so, we're not going to fully detail. I mean, the definition of decreasing follows along, but decreasing, yes, look for negative slope. And so that's how you identify increasing and decreasing. And then for constant, just to look at the definition, when we have different x's, f of x1 equals f of x2, that says y1 is equal to y2. Well, what kind of graph do you have if all the y values are the same? You have a horizontal line. So increasing intervals look like positive slope, decreasing intervals look like negative slope, constant intervals look like, I didn't write it, horizontal line. Look for horizontal. Like it's spelled today. All right, so that right there is the concept for increasing, decreasing, or constant intervals. Now we got to make sure we can answer the questions correctly. And so here's where people get tripped up. It's how to answer the question. All right, so how do we use those x and y values? So we use the y values to tell if it's increasing, decreasing, or constant. And the reason we could, when we talk about slope, we it's that rise over run idea. But since we're always going to the right, that means if you think about rise over run, that means the run is always positive. So we're really just, if you can look and see how the y values change as you go to the right, that tells you which one of these we're in. So you look at the y values to see if it's increasing, decreasing, or constant. So is it increasing? I would say increasing, decreasing, and constant. Definitely going to abbreviate those. So you look at the y value to see what it is. Now we answer using x values. Okay. So really, when we're talking about intervals of increasing, decreasing, or constant, we're talking about parts of the domain. So we're always using X values to answer these questions. All right, and so one of the things that I do, because we need to identify the critical points on a graph to know when it's going from increasing, decreasing, or constant. But one of the things I recommend that all students do is like as soon as you get all those points identified, I cross out all the Y values. Because we don't need the Y values in the answer, we need just the X values. That is by far the most common issue with this topic, is using the Y values in the answer. All right. Okay, so this, again, I apologize for the small graphs, so I'm going to redraw this on my paper a little bit bigger. But basically, we have this graph that is looking something like this. There should be arrows on both ends. So let me reproduce that on my paper so we can actually have a more decent view of it. So something like this, it's often easier to draw in the picture first and then put the points later. It may not be exactly at the scale, but again, I'm trying to make sure we can read it. So this point here is -3, -1. That point there is -2, -3. Now that is 0, 0, but that's actually not important to what we're doing. And the reason it's not important is because, yes, that's an intercept, but what we're talking about now is where is it increasing, decreasing, or constant. So we really just need to know where does it change from those different categories. All right, so first of all, before we, just make sure we can identify the overall picture. So where is this increasing? So where do we have a positive looking slope? Oh, right here in the middle. So this is increasing. So where is this decreasing? It's decreasing just to the left of that because now we have a negative slope. And so what does that leave these two? Well, by the way, that is supposed to be horizontal, not quite parallel to that, but you get the idea. So we have two horizontal lines, so we have two constant pieces. Now, when you're answering the intervals for increasing, decreasing, or constant, you can either like answer them in the order they ask, or sometimes I like to just start on the left and go to the right, and say like this interval is this interval is that, and so on. I think more people are just kind of do it in like in the order they're asked. So let's start with increasing. So where is this graph increasing? All right, so remember what I said earlier is since we don't want the y's in the answer, let's see, totally block out those y's. All right, if you do that, you have no excuse to put them in the answer, right? Because we only need the x values. So where does this graph start increasing? So right here, remember when we're doing domain, we're always go left to right. It's the same way here because these are parts of the domain. So go from left to right on any interval. And so we're starting at -2. And again, put parentheses with these numbers. And then how far do we go to the right where we're increasing? Well, we stop increasing at 2. I'm going to do the decreasing and then I'll come back and explain why we put parentheses. And so there's only one interval there. So where it's increasing, so we only have one interval in our answer. All right, so where is this decreasing? Okay, well, decreasing is where we have negative slope. There's only one interval that has negative slope, so we only have one interval in our answer. Okay, so where does it start decreasing? So on the left, it's -3. And where does it stop decreasing? Well, they're at -2. All right, now this is why we use parentheses. Well, one, other than the fact that, remember in the formal definition it said open interval, and I said open interval means we use parentheses. But the explanation of why with that is, look at this point. So at this point right here, on the left-hand side it's decreasing, on the right-hand side it's increasing. What happens right at that point? Well, is it decreasing or is it increasing? It can't, it's a transition point. And so since it's a transition point, the formal definition of increasing, decreasing is it has to be like doing the same on both sides of the point. So if I picked on, say, that point, that's increasing on this side, increasing on this side, so I can say that point is increasing. Or if I do that point right there, it's decreasing on this side, decreasing on this side, so I can say that point is decreasing. But at this point and at this point, it is transitioning from one, from increase, decrease, or constant to the other. So at that point, it cannot be just increasing or just decreasing. That's why we're using parentheses. Okay. So just, well, if that doesn't make sense, just try to remember that when you're answering increasing, decreasing, and constant intervals, always use parentheses with every number, plus, positive, negative. This is something where on the test, I mean, in the homework, you'll see this. MyMathLab would, or it should, unless they've changed things, it's definitely going to count it wrong if you put brackets. On the test, if you put brackets, I'm probably going to take just a half a point off, because I'm far more concerned about you getting the right X values. The brackets and parentheses are, the minor part of this. But if you do that mistake constantly, that is going to add up. All right. So increasing is positive interval, decreasing is negative. And now what about constant? All right, so constant means we're looking for a horizontal line because the y values are not going up or down. And so we have two horizontal lines. And since we have two horizontal line segments, we're going to have two intervals. Okay. I think I briefly mentioned this in the last video, but there's something kind of new with this. It's not uncommon to have two interval answers. Okay, so let's start on the first one. So what is the interval for that piece? So how far left does it go? Well, it goes to -infinity. And then how far to the right does it go before it starts decreasing? It goes over to x equals -3, and then put -3. And again, always put parentheses with this. Now, when we have more than one segment, we're going to put what looks like a capital U without the little leg. This is for union. Which union roughly translates to or. We're saying, the interval, the x's can be this interval or the next interval. The MyMathLab is looking for the U. There might be some problems where they coded it so you could put a comma between the two intervals, but in general, we're using that U for the union. It means this or this. All right, so what about this interval? So we have another horizontal piece. So the interval from left to right is it starts at 2, goes to positive infinity. 2, infinity. So when you're answering for increasing, decreasing, or constant, we're looking at the domains, and we're always using X values. Like I said, I wish more people would actually just go through and cross out the Y values for increasing, decreasing, or constant because they don't matter. Now, I think part of the reason they don't is when we get into maxes and mins, we need the Y values. So, you keeping those straight is important. But like I said before, that's one of the challenges of this unit is keeping all the details straight. Okay. There's number 3. So again, I'm going to redraw this in my paper so we can get a better picture of it. But now we have this upward parabola, and that little bottom part's the vertex, and that's over there in quadrant 4. So let's redraw that, get a better picture, and then answer the same questions. Graph looks something like this. And we have to assume arrows aren't at the ends because they don't put any like open circle and closed circles. All right, and so what point or points are important on this graph? So if we're looking for increasing, decreasing, and constant, well, the important points are where it transitions between the different categories. So where would you say this graph is increasing? You know, just in general. So where does it look like a positive slope? Well, over here on the right. It's increasing. And this point right here is going to be important because that's where it starts increasing, right? Is this increasing? Sometimes students will say yes when we first start doing this because you look at that up arrow and think it's going up. But remember, we're talking positive and negative slope basically. So as we go to the right, this is still going down. So this is not increasing, this is decreasing. And so again, the transition is that vertex point. So that's the only point we actually need on this curve. All right, so what is that? That looks like 3, -2. Yeah, yeah. We're going to call it 3, -2, whether it is or not. All right. So if we're going to answer for increasing, decreasing, what do we use? We use the x values only. So I do not care about that -2 whatsoever, not in the least. All right. So where is this increasing? So where does it start increasing? It starts increasing at 3. The parentheses 3. Where does it stop increasing? Well, never, because it's increasing forever to the right. So that would be from 3 to infinity. This function is increasing. It's going up from 3 to infinity. Okay. Now, where is it decreasing? Well, this left-hand side is where it's decreasing. So where does it start decreasing on the left? Well, again, even though that's an up arrow, remember, as we go to the right, it's going down. So this is start decreasing over here at -infinity. Where does it stop decreasing? Right here at this point. And we use parentheses with all our numbers for increasing and decreasing. All right. So that is increasing, decrease. What about constant? Where is this function constant? All right. And this is where, like in class, when I ask this question, I almost always hear that point right there is where it's constant. But it's a good guess, but a single point cannot be increasing, decreasing, or constant. You always need like the points on either side of it to have the same pattern. So a single point that is not constant. To be constant, you would have to have a graph that would come down, have a horizontal, like flat bottom, and then go back up. That would be constant. Right, but since we have just a single point that's transitioning from decreasing to increasing, there is actually no intervals where it's constant. And if we're going to check MyMathLab as always. I think they have an option for none or does not exist. When we get into MyMathLab, we'll see how they answer that. But there is no horizontal segment in this graph, so there is no constant part of this graph. It's just decreasing on the left, increasing on the right. Okay. So if we go to the next page, this graph we might actually be able to see. All right. Now notice there's -pi, pi over 2, pi, and -pi over 2. If you're wondering why are we doing pi stuff, this is for those who are going on to trig. In trig, you deal a lot with circles, and so anytime you're dealing with circles, you're dealing with pi. So these x values are coming from a trig function, the pi's. Okay, so weird number looking number aside, we're still asking where is it increasing, decreasing, where that F came from, and constant. So let's do the constant part first, because I think that should be the quickest part of this. Where is this function constant? There are no horizontal segments whatsoever. So there is none. Okay. All right. So where is this increasing? Well, where does it have a positive slope? Right here in the middle. That's where it looks positive. So that's our increasing. Where is it decreasing? Where does it look like a negative slope? Well, on the left side and the right side, where it's decreasing. Now, and especially if you're a visual person, take the time to, like I'm doing, and like circle the different segments. So that way, when you answer, you can go back and I just think it helps. I think a lot of times answer these questions. All right, and so now when we're going to answer these, are we using the x's values or the y values? We were saying x's. Let's cross out all the y values. I do not care about any of those y values. Now, do I care about this 0.02? Is it going to be part of this? No, because that is like a single point in the middle of that increasing interval. So on the intervals, all I care about is the left side and the right side. So I do not care about that point either. The whole point. It's not important. All right. So where is this increasing? So on the left, what is that x value? It's negative pi over 2. Which, by the way, pi should be one of your buttons. And, like when you click on the answer box and get that button palette below it, pi should be something in there. Where does it stop decreasing? On the right. Now it's pi, x is pi, positive pi 2. Okay. All right, now where is it decreasing? So this one has two areas with negative slope. Yeah. And so for this first one, where does it start decreasing? On the left, it's negative pi. On the right, it's negative pi over 2. All right, so now we have a second segment. So what do we put in between those two segments? Unless it tells you can put a comma between them, you're going to have to put in that U for union in between if you have two different segments. So now what is the segment or the interval for this piece? Well, it starts decreasing at pi over 2. It stops at pi. And the reason we're not going to infinities, like we're not going to negative infinity over here, positive infinity over here, those are closed circles, not arrows. That's telling us it stops right there. It does not go on forever. All right. So, what would you do with number 6? So sometimes MyMathLab asks the question a slightly different way. And so what are they asking here? So the graph of the function is given. Determine whether the function is increasing, decreasing, or constant on the given interval. So on that given interval, that's that 3 to infinity. So what are they asking? Well, where is 3 to infinity on this graph? Well, remember that's x values. So where is x equals 3? Again, I apologize for the small print, but that's where x is 3. That's where x is infinity. So what they're saying is they're looking at that interval. So what is that interval doing? It's decreasing. So that's the two ways in MyMathLab you're going to have to answer these questions. Either they're going to give you the picture and then just say, where is it increasing, decreasing, or constant? Or they're going to give you the graph. They're going to give you one interval, and they want to know for that interval, is it increasing, decreasing, or constant? And like I said, once we get through all the notes here, then we'll get into MyMathLab, and I'll show you that more specifically. All right, so that is topic number 1 from section 3.3. Now we're doing topic number 2, which is maximum and minimum. or minimum. Now on this one, again, it's a detail thing. Is there are two types of maxes and mins from a highlighter. Right, so there are, and to make it even more fun, both types have two different names. So there's local or relative maxes and mins, and then there are absolute or global maxes and mins. All right, so keep in mind when we're naming things in math, we tend to be very particular and very direct about how we name them. So if you have a local or relative maximum or minimum, how is it different from an absolute or a global max or min? Well, a relative or local max or min is a max or min in a small area. Okay. And so graphs can have multiple local relative maxes or mins. Um, and once we get into graph, I'll explain a little bit better. But there can be several of these in a single graph because those are just in a small area. Whereas an absolute or global max or min is the overall, the single highest or lowest y value. So there's only one of these at most. Sometimes there's not any, depending on the graph, and I'll explain why. So that's the difference between these. Is locals or relative maxes or mins are in a small area. There can be several of them. Absolute or global maxes or mins are the single highest, and sometimes there's one, sometimes there's none. And sometimes the relative max or min can be the absolute global max or min. Sometimes they happen at endpoints. So there's a lot of different possibilities going on that's why we're doing all these examples. But specifically, if and I did all this for maximum, it all works in the opposite direction for mins. And so when we're looking for absolute max or mins, like if we're looking for the absolute max and our graph, like if our graph goes up forever, there is no single highest y value. So this would not have an absolute maximum or global maximum because it goes up forever. Now it is going to have a absolute minimum because there is a lowest y value. And so that's, you do have to, for absolute max and mins, that's why sometimes they don't occur because if you're going to infinities or negative infinity, you don't have. All right, so let's see. Yeah, so the local mins or maxes. So these are on our graph. We're going to look for mountain peaks. I have those somewhere here. Okay. So for maximums, look for mountain peaks. The relative. What I mean by mountain peaks, that's a mountain peak. So that y value is higher than everything, all the y values around. Now, this point right here, this is not a mountain peak because the graph stops. So I don't know. It could keep going up. It could be coming back down. But to be a relative maximum or minimum, you either need a peak or what would be the opposite of a peak for minimum. We call them valleys. So local mins and maxes are either peaks or valleys in our graph. And again, like you might look at that and say, well, is that a relative minimum? No, because I don't know like what this graph is actually doing. It can keep coming down, like go down forever. It could go back up. So you have to have something on both sides. Again, you have to have a mountain peak or a valley to get a relative max or min. And then the absolute or global maximums and minimums, like I said, it's the single highest one. So if you look at this graph, where is the highest y value? Right there. So that's where your absolute max is. Where is your overall lowest y value? Well, right there. So that's your absolute minimum. Now, if this continued down, like if that went forever, this would have no global minimum because there is no lowest y value. You're always going to get lower and lower. All right. So, like I said, I think the idea is relatively straightforward. But now here's where you have to be careful about answering the question. And so if they want the max or min value, that is the y value. All right, so that's what's the highest point, what's the highest value, what's the lowest value? We're talking y values. Okay, if we're talking about where it is or where it occurs, that's the x value. All right, and then sometimes they're going to want it as an ordered pair. So depending on how they ask the question, you may be answering the y value, you may be answering the x value, you may be answering the point where it occurs. And that could vary from problem to problem. So again, that's one of the little mini details that you have to pay attention to when you're doing this. Let's just jump into some problems. Let's see how this goes. All right. Yeah, I really wish I had a nice program that would let me draw these. All right, so for number 11, so first of all, let's slow down, read the problem, make sure we know what we're looking for. All right, so find the numbers, if any, at which f has a relative minimum, and then what are the relative. So this is actually asking two questions. So it says at which it has a relative maximum. So when it says at which, is that the x or the y value or both? Well, at which is the x values. And when it says what are the relative max, what are they wanting there? Well, the maxes are the y values. All right, which one? I don't know why they said max there. Okay, so we're dealing with just max on this problem. Okay. All right, so once we do that, and then when it says give the coordinates, what does the coordinates mean? Well, the coordinates, that is both x comma y. So when it says coordinates, we want the point. So this is where you have to, like I said, you have to pay attention to how the question is worded, because first thing they want is the x values, second thing they want is the y values, third thing they want is both. Okay, and for this one, we're just talking about maxes, not mins. All right, so let's go through. All right. Okay. Again, this is kind of small, but we'll stick it on stay on here. All right, so the first thing I want is at which f has, so find the numbers, so let me put this one. So where is the relative max? All right, so how do we find relative max on this graph? Well, relative max means we were looking for a mountain peak. So where's the mountain peak on this graph? Right here. All right, so let's see. That point is 0. Yeah, so let's say that point is 0, 1. Just is there any other relative max on this graph? No, because there is no other mountain peak. Okay, we can definitely, if I gave you a graph that looks something like this, that would be 1, 2, 3, 4. Oh, sorry. 1, 2, 3, 4 relative maxes. And that would be 1, 2, 3, 4 relative mins. And so if you have multiple mountain peaks, multiple valleys, you can have multiple maxes, relative maxes and mins. All right. So now that we've identified the point that is a relative max, where is the relative max, or what numbers, if any, at which it has a relative max? That's the x value. Now in the notes, I'm going to put x equals just for emphasis. In MyMathLab, they just want the x value. I think it would help, to say x equals or y equals like outside the answer box that we commonly do. I don't think they normally do that. Now, second question is, what are the relative maxima? In this case, just the one. That says, what is the relative max? Well, we're saying, what is the maximum? That's the y value. Okay, and so the y value is 1. So that's the answer that you'd be putting in that one. Okay, again, if you put the x equals y equals in there, they will count it. But that's the important part of this problem, is knowing which one is which. Now, when it says the coordinates of, now remember, local is the same as relative. So when it says coordinates, it wants the whole point. So that would be 0, comma. So that's the challenge in the max or min problems, is making sure you can answer it correctly. Which I guess you could say that's the challenge in any math problem, but it's not like you're doing algebra to solve here. This is just identifying a point and then what part of the point do they want. Now the other question was absolute max. So does this graph have an absolute max? Well, because there's no point on this, we have to assume that graph goes on forever. And so if we're making that assumption, there is no absolute max. Because this graph goes up forever, so it does not have a single highest y value, because it just, any y value you can think of, there's always going to be one higher. All right. How about the next one? So for the graph of the function below, find the absolute max and min. If it exists, find local mins and maxes. All right. Now notice here it didn't say in these instructions, like it's not clear on if they want just the x value, just the min or max, or the point. With this language, MyMathLab is going to be more specific than that. With this language, when it says just find them, to me, that's going to be the y value. That's how I interpret it. But like I said, MyMathLab is going to be more specific. All right, so it wants absolute max, it wants absolute min, and it says local mins and maxes. With a local min and then the local max. All right, so what is the absolute maximum of this graph? Well, that's the overall highest highest point. And so since we're looking at just y values, that would be 6. Okay. What is the absolute min? So what's the overall lowest? Okay. Now you always have to look at endpoints. Actually, let's modify this graph a little bit. To make it a little bit more interesting. So continue that down to 8, -1. And so now that I have that, what would be the absolute min? Well, now it'd be that point. So if we're looking at y values, it'd be -1. Before I change that, the absolute min would have been 1 because that would have been the lowest y value. Right. Now, what is the local min or mins? So we're looking for valleys. There's only one valley. This is not a valley. This is the only valley. So what is the y value? Is 1. And then for the local max, we're looking for any mountain peaks. All right, so there's the only mountain peak. That is not a mountain peak. So the only local max we have is that point. So it'll be 6. So sometimes our local mins and maxes can also be our absolute mins and maxes, but you do have to look and see if anything's higher. Okay. Okay, well, we're going to look at a couple more of these in MyMathLab, but this is again, I think one of those concepts that's relatively straightforward to know what we're talking about. It's the challenge is how to answer the question. All right. Now this formatting thing on this so we're now talking about odd or even. And so when we're talking about odd or even functions, so we're going to do the algebra version of this and the graphing version of this. Okay. And so this is, to be able to do this, one, you have to know your definition. Now, this starts with the algebra definition. I want to start with the geometry definition because that's a little bit less quicker to explain. But we're gonna do both definitions before we do the examples. And so the geometry definition of an even function, it's symmetric with the y-axis. So what that means is like a parabola is if it like say we have a parabola that starts at has a little low point at 0, 0. So this would be even because when we're talking about symmetry, we have we can say it's symmetric with the y-axis. So that part right there is where you fold it. So if you think about this like on a piece of paper, if you fold this graph like this piece and fold it over, it'll lie right on top of itself, or vice versa. All right, so that's if you fold it through the y-axis and it lays on top of itself, that means we have an even function. Now for an odd function, it says it's symmetric with the origin. What that really means is you have to fold it across both the x and y-axis to get it to lie on top of itself. And so a common example of that, something when we're talking about x cubed, you don't need to know this is x cubed and x squared until next unit. But this is our odd function. And the reason it's an odd function is when you have to fold it across both axes. Doesn't matter which one you do first. But let's take this piece. So if we fold it over the y-axis, it would look something like that. Now if we fold it across the x-axis, that piece is now going to fold down. And so then it would lie right on top of itself. Right? Or you could take this piece, fold it across the y-axis, then it would be here. Then you fold it up, then it would be there. So that is the geometry definition of even and odd functions. It's really about symmetry. And so the reason we're talking about this, like in calculus, if you have functions with these symmetries, they're, I guess, nicely behaved might be a word. And so they're not as messy as ones that, if you fold it and they don't lie on themselves like this, they're neither even or odd. And so those are just messier functions to deal with when we're doing a lot of things in calculus. So that's the geometry definition. All right, so I think that's the one that makes a little bit more sense because especially if you're a visual learner, but we also need an algebra definition. And so for the algebra definition, an even function means, I guess probably get it in the side. All right. So an even function means that f of negative x is equal to f of x. That's how we define it. What does that mean? Well, this goes back to function notation. That's why this is in the properties of functions. So what does f of negative x mean? That means in your function, in your equation that you have, you're going to replace all your x's with negative x. Now, when it says that's equal to f of x, what that means is after you plug in negative x and like clean it up, you should get the exact same thing that you started with. I mean, we're going to do examples on this, but that's what, this is the algebra way that we find even and odd. We're going to plug in negative x, we're going to clean it up, and then see what we end up with. If we get exactly what we started with, it's even. And then for an odd function, we're going to do the same thing. We're going to plug in negative x, we're going to do the algebra and clean it up. Now that says it's equal to negative f of x. And so what that means, what negative f of x means, that's the opposite of f of x. So that means every single sign has to change. So an even function, an odd function, the first step in both of them is replacing x with negative x. And then if after we cleaned up, we get exactly what we started with, it's even. After we cleaned it up and all the signs are changed, then it's odd. If some of the signs change and some of them don't, then it's neither. And when you're doing this, please use parentheses when you're plugging in your negative x's. Okay. All right. So that's big picture. But now let's see what these problems look like. Right. Again, we're going to start with the graph part because I think that goes a little bit quicker. So for all of these functions, decide if they're even, odd, or neither. So that means to be able to answer this, you have to know how to where the fold is that we're looking for the symmetry. So remember, even means we're going to fold it across the y-axis. Odd says we're going to fold it across both. And it has to lie on top of itself. If it doesn't on either of those, then it's neither. All right, so when you look at number 14, I always like to start with even because even is just one fold. If it's odd, you got to do it across the y-axis anyway. So if we take, just take basically half the graph. So if I take this part of the graph and fold it over, is it going to lie on top of itself? Well, one of the things you definitely want to look for that helps, notice, and again, it's kind of small, but notice like the bottom there is right on the y-axis. That's important. So what that means when we fold it over, this is symmetric across the y-axis. So that tells us it is even. So if you just fold it across the y-axis, you get the same piece, it's even. Okay. So how about the next one? So take, it doesn't matter which piece, top or bottom, just take half of it. So if we take this and fold it across, we're gonna get something like this, right? So this is this even? No, because when we fold it over, we don't, there is no graph there. So this is not even. But what happens when we fold it across the other axis, so take this piece and now fold it down, now we get that graph. So this is symmetric across both. That tells us it is odd. Okay, so fold it once and then fold it twice. Or you take this piece, and again, it doesn't matter like which folding you do. If you fold it, you fold this piece across the x-axis, it would fold up to there. And then you fold that piece across the y-axis, then you get that. So that's what you're looking for even and odd. And so you fold it once across the y-axis. If we get the same piece, we're even. If you have to fold it across both, it's odd. And so now I'm going to give you one that's neither. And so like that's sort of like the middle of the graph. So that's notice that it's on the y-axis, but it's not on the origin. So what's going to happen? Like if I take that piece and fold it across the y-axis, we're going to get something like that. It's definitely not even, right? Because that does not fold over to here. Now, what if we take this and fold it down? Well, this is a little bit trickier, but remember, if we're folding it right here across the x-axis, like this whole thing is going to flip down. So like that's going to flip down to here. And so it looks something like that if we fold it down. Because the starting point, it starts at +2, so when we fold it has to be at -2 when we fold it down. So that is definitely not, that piece because it's definitely different. So this is not even, not odd, so it is neither. So we're looking for nice symmetric stuff, for even and odd. So if it's So if it's like this one, when I look at it, to me, that's off kilter up and down. Like if that had been in the right at the origin, then that would have been odd because then it would have the folding would have worked when we did a crossbow. Yeah, and pretty much all odd functions have to go through the origin. Well, like I mean, this one doesn't, but it's like so. I guess it's evenly grouped around the origin. But if you know, but there's gaps on this one. If there's no gaps in the function, like this one, it pretty much has to go through the origin if it's going to be odd. All right. What about this one? So is this even, odd, or neither? Well, if we take this piece, fold, and again, I always like starting fold across the y-axis, that way we can check for even, or it's the first step of checking for odd. So if we fold this across, that would look like that. So it's definitely not even. Now, is it odd? Well, we now fold it down. We fold it down, then we get that piece. So this is odd. Okay. And if it helps, like just even like you could physically fold your paper, and then does do those two pieces match, when you bring them, or if you have a little mirror, you could even like hold up the mirror and however you want to play with it, right? That's what we're looking for the geometry definition of even or odd. Even, does it work? Is it symmetrical when you fold across the y-axis? Odd, fold it across both the y-axis and the x-axis. And if you get something that doesn't line up when you do it, then it's neither. All right, so that is the geometry definition of even and odd. And so now we have to do the algebra. So remember, when are doing this algebraically, step one is always replace x with negative x. Okay, and then we're going to clean it up. So we're doing f of negative x. That's the function notation for that. So in this case, we only have one x, so it's going to be 5. And please use parentheses. Okay. And so now you have to clean it up. And so basically, and the reason parentheses are important is tells us how many negatives we're going to have. So when you cube a negative, that's negative times negative times negative, that's overall negative. So that would be negative 5x cubed. After we clean it up. All right, so that's step one. Step two, now we compare it to the original. So if it's exactly the same as we started, it's even. If all the signs are changed, it's odd. If it's anywhere in between, it's neither. So is it the same that we started with? No, because we had positive 5x cubed, now we have negative x cubed, so it's not even. Is it the exact opposite? Well, we started, that was a positive 5x cubed, now we have negative, so this is odd. This is getting kind of crowded, so I want to go to the page here. So let's do the next two. So for 19, we have f of x is negative 5x to the fourth minus x squared. So is this even or odd or neither? Step one, what is f of negative x? We're going to place all our x's with negative x. We have negative 5, parentheses, negative x to the fourth, minus, parentheses, negative x squared. Okay. Now we got to clean it up. So when we have x, negative x to the fourth, is that positive x or is that negative x? Well, we're doing 4 negatives, so that becomes positive. So that is positive, positive times negative. Clean up and compare. That'll be negative x to the fourth. And now over here, negative times negative would be positive x squared, but we have the negative here, so it would be minus x cubed squared. Because like, or if you think of it, overall we have 3 negatives here. 1 negative from here, two negatives from this one. So now compare that to what we started. Negative 5x to the fourth minus x squared minus x squared. That's exactly what we started with. So f of negative x equals f of x. That tells us that it is even. So if it's exactly what we started with, it's even. Everything changes, it's odd. Now, do you see a shortcut that we might be able to take? Like y18 is odd where 19 is even? Well, if you're looking at the exponents, 18, you have an odd exponent and the function was odd. 19, you had two even exponents and it ended up even. You're close, but you have to be careful with this shortcut because what if you have a constant? Okay, as long as you have nothing but x's, you can actually go by the exponents. So if all your exponents are odd on your x's and you have no constants, it's an odd function. If you have no constants and all your exponents are even, you have an even function. If you have a mix, like if you have an x to the fourth and x cubed, it's automatically neither. But where you have to be careful is if you have a constant. So let's look at number 20, which is 6x cubed plus 9. Okay, so you might look at that and just say automatically, well, it's odd because the exponent's odd. But let's do the algebra and see what happens. Okay, so step one is put in negative x. Not step -1, step one. So f of negative x is 6 times negative x cubed plus 9. So now we clean that up. So overall, is this positive or negative? Well, we have three negatives overall, so this is a negative. All right, so that's step one. Step two, compare it to what we started with. All right, so those are opposite. Okay, so it's definitely not even, but that's the same. Opposite, which is good. Same, which is bad. Well, if it's even, we'd want them all same, but since we have a mix, this is definitely 9. I before E. But you know how some words always look spelled wrong no matter how you do it? Okay. So this is neither even nor odd because it's not exactly what we started with. So it's not even, it's not exactly opposite what we started with, so it's not odd. And so here's where you have to be careful is if you were just trying to do the shortcut and say, well, that's got an odd exponent, so it's odd. What is the exponent on this 9? Well, what's the degree of a constant? Well, it's 0 because that's like having an x to the 0. So actually constants are, if they're in, that makes it, that part of it itself is even. So then you have a mix of even and odd exponents. So that's why it's neat. So you do have to be careful with the shortcut. But I know some people are going to see that and try to do it on everything, but the constants mess that up. So if you see a constant in there, it's either even or nothing. If you have no constants, then you can, and again, normally I would, recommend plug in negative x and do all that. But there's so much going on in this section. If you can use those shortcuts wisely, then I'm good with that. Because you're still using your math knowledge, right? So, we don't always have to do all the work to get to the answer, right? Okay, so that is the lecture notes. Now let's go into MyMathLab. If there's anything else we need to talk about. Okay, so we are doing 3.3. Now this looks relatively short because there's only 14 questions. However, they really love their multiple part questions here. Not so much here, but you'll see it later. All right. So use the graph of the function to answer the given question. So is f increasing on this interval? Okay. See, this is where I would automatically say no because I use brackets. So it's, sometimes MyMathLab can ignore stuff that bugs me. Sometimes, that goes the other way. But let's ignore the brackets and the parentheses. Let's just look at the interval. So this is saying from x equals -2 to x equals 1. So x equals -2 is here. X equals 1 is here. So what is that graph doing from -2 to 1? On the x-axis, it is decreasing. So it is not increasing. All right, same idea here. So is f decreasing on the interval from -1 to 1, or sorry, -5 to 1? So there's -5. Where is 1? So it's this whole peak right here. Well, it's decreasing on part of it, but it's also increasing on part of it. So that better be a no. Okay, so that's why that one's a no, is we're looking at increasing and decreasing, not just decreasing, because that's the interval they gave us. Okay. Was there any more? Okay, so now this is one, like this is where, what intervals is it increasing? And now notice it didn't say increasing, decreasing, constant. This is one of those that's random. Like if you do it again, it may pop up decreasing or constant. But that's where is it increasing? So where are your positive looking slopes? All right, so right there, that's increasing. Right there, that's increasing. And then at the end, it's increasing. So this one is going to have 3 intervals. Okay. Well, remember I told you about union, and now here's one that says use a comma to separate the answers. It really bugs me when MyMathLab is inconsistent on this. All right, but like I said, I would, I like the fact they're letting you use commas. I just wish they would be one way or the other. So let's start with it. So where is this increasing? So remember, use the x values. So that's it. Starts increasing at -10. Oh, and this is, since we're using open intervals, you can use your ordered pair to just put the parentheses in. But starts increasing at -10. And then it stops increasing up here at x equals -4. Then we have 2 more of these, so we'll do a comma. And then this part is increasing, so it starts at -2. I'm doing my ordered pair again to get the interval. Where does it stop increasing here in the middle? That's on the y-axis. That means x is 0. And then we have a third part that has a positive slope at the end. So it's going to start at, see, that's x equals 3. It goes over to x equals 5. So this is a bit messy to read, but if it helps, you may want to since in this case, like I said, we're talking about increasing. So you may want to go through and label those points that are in question, cross out your y values, and then go from there. All right. And then there's going to be more increasing, decreasing later because they do multi-step questions. So is there a local maximum at x equals -1? So over here at x equals -1 is right here on the graph. Is that a local max? Yes, because local maxes look like mountain peaks. That is definitely a mountain peak. So we're good. Notice it didn't ask you what it is. Oh, no, it did now. So yes, so now that there is a local max, said the local max. Now this one, they actually put the y equals out in front. So again, pay attention to that. But remember, when they're asking for maxes or mins, they want the y value. So what is the y value of that point? See, we're counting by ones, so that would be 1. Now, if it wasn't a local max, notice that you'd have the option of saying there is no local max. All right. So there's a variety of ways they can ask this. So list the values of x, and they are, yes, they are nice at putting the x equals out here, at which it has a local minimum. And so they're not, so it says, so what's the x values, not the y values. And we want local mins. And so what are we looking on for local mins? We're looking for minimums or valleys. So how many valleys do we have on this graph? There's 1, there's 2, and that's it, because that's not a valley. Now this is where I thought my graphs were small. These are still kind of, so is that, so here's where is that -10 or is that -5? So 1, 2, 3, 4, 5, 6, 7, 8. That's 9. So that's -9. And then use comma to separate answer. So we have another valley. And so what is the x of the other valley? That would be 1, 2, 3. Here we go. Okay. Now, what are these local minima? Okay. Now, this is where, so when it says what are, those are the y values. So what is the y value of this one? So that's 5, 6, 7, 8, 9. So that's -9. Now, notice that they're the same. Let me check this right quick, because in the past, MyMathLab would count it wrong if you repeated it. We talked about, like, MyMathLab doesn't like repeated answers. Let me check over here. Okay, they accept repeated answers in the Maxima. So I wasn't sure that they would. Like if you had just put -9 on this because they were the same, I would accepted that, because I would assume that you looked at it and only put 1 because they are the same. All right, so that's maxes and mins. Same basic idea. Still local maxes and mins. We're still looking for mountain peaks and valleys. All right, so now algebraically determine if it's even, odd, or neither. So this is where you plug in -x, and then it's exactly the same. It's going to be even. If everything is changed, it's going to be odd. If some signs are changed, some are not, then it would be neither. We just did those examples. All right, and then at the end of this, they get into like putting them all in the same one. So find the following: the intercepts. So how many intercepts does this graph have? Well, let's see, it touches the x-axis twice, the y-axis once, so there's 3 intercepts. And notice it says type is an ordered pair. Again, you have to get in the habit of reading these instructions. Okay, so let's just go from left to right. So the coordinates of that one would be pair. Oh, look, they have the plus or minus when we don't need it. All right, so that is -1, 0. And then comma between them. So the next intercept will be our y-intercept. So that would be 0, 1. And another comma. We have another intercept. And so that third intercept would be at 2, 0. So this is more of a chapter 2 question, but we're going to be talking about intercepts, a lot in this unit and the next. So that's still a good question. Okay, the domain. So how do you answer domain? When you have a graph, you go how far left, how far right. Now notice there are no arrows on this, so we're not going to infinity. So the left side is -3. Do we put parentheses or brackets? Well, there's a closed circle, so closed circle means bracket. Then how far to the right does it go? That right side would be at x equals 3. Again, it's a closed circle, we're putting brackets. Now, what's the range? How do you answer the range of a graph? It's how low does it go? How high does it go? So the lowest y value is right there on the x-axis, so that's y equals 0. How high we go, it's 1, 2, 3. Those are the highest y values. And so you're going to be seeing domain and range questions the rest of the semester. That's not just a 3.1 thing, or a section 3.1. Okay, and then it asks for increasing, look, it's going to be increasing, decreasing, or constant. So there's 1, 2 intervals where it's increasing. There's 2 intervals where it's decreasing because it's negative slope. There is no horizontal, so there would be no constant. So it's going to, you have to go through and answer them in order. And it says use a comma to separate. So maybe all the ones I picked don't have the union. You actually put the union, the comma between the 2 intervals, which would be nice. And then is this even, odd, or neither? Okay. Well, so always start by folding it across the x-axis, or sorry, the y-axis. And so it's kind of symmetric, but not exactly, because like when you fold this, that starts at -1. So when you fold it over, it would be a +1. So these bottoms are definitely different when you fold it across the y-axis, and there's nothing in the bottom, so you can't fold it across the x-axis. So this one would be neither even nor odd, because there is no symmetry when you fold it anywhere. So those are the types of question at the end. They're going to give you a graph, and you're going to have to answer multiple questions about it. I like This is a preview of something we're going to see in Unit 4. I want to talk about the increase and decrease or constant. So if you look at this, what is this graph doing? Well, isn't it increasing the entire time? Like over here, it's very obviously a positive slope, but even here, even though it's not as positive, it's still positive slope. So this function is actually increasing the entire time. So from negative infinity to positive infinity, it's increasing and doing nothing else. That red dotted line is not actually part of the graph, but when we get to Unit 4, we'll explain why that dotted graph is there. So just look for the blue part of the graph. And then same idea. And for this one, is there any symmetry at all in this graph? No, because like when you fold that over, it's definitely not folded across there. If you fold that, there's no symmetry on that one. Same with 13. It's a nice smooth graph, but it's definitely not symmetric with the y-axis because you don't get that. And there's nothing down here in the bottom, so there's no symmetry on that either. All right. So like I said, the challenge on this is make sure you can answer the questions as they were asked. So hopefully you're not procrastinating on this, because it just, if you miss it, then you need time to go back and figure out exactly why you miss it. But reading the instructions is key to being successful in this chapter 3 stuff. All right, that's all I have. So have a good day, and then I'll see you soon for I think the piecewise function video is going to be next. Okay. As always, if you have any questions, please email me.